Hello everyone, my name is Sajak Kasky, and today I will be demonstrating my team's work for part 3 of a course project for the DevOps and Secure Software Development class, which is offered by Ross Young and Jeff Onzik at the Johns Hopkins University Whiting School of Engineering. Today I'm presenting on behalf of Team 7, which also includes my teammates Lucas Garbs and Clint Sullivan. So today I'll be giving a walkthrough of the configuration steps that our team took to set up a continuous integration process, which performs dynamic application security testing on a Juice Shop Docker container, which is an open source and intentionally insecure web application that's used for DevOps training and cybersecurity awareness purposes. The CI job is a combination of using Docker Compose to deploy a set of infrastructure services, which include GitLab and Jenkins. This infrastructure is set up such that every push to the remote GitLab repository for the Juice Shop project will trigger a job to execute within Jenkins. The job that has been defined for this project pulls a Docker container image from a container registry within GitLab and then uses a tool called Snick to perform runtime scans of the container, testing for security vulnerabilities. The success of this job is determined by whether or not any vulnerabilities were found during the scan, giving developers a quick analysis about the quality of the container images that are being generated from the codebase changes. So without further ado, I figured we could look at the Docker Compose YAML file that we have set up for this project. So within my /GitLab directory here, I'm on a AWS EC2 Linux distribution too, by the way. So this is a cloud VM. But if we go into the docker compose.yaml file, we can see that there's 3 sections here, one for each service that we're going to be deploying through Docker Compose. This first one is called Web, which pulls a Docker image for GitLab. The second one is our Jenkins image, which pulls the Jenkins long-term support image. And then this third one, SonarQube, was used for part 2 of the project, so we won't be talking much about SonarQube today. But this is the full configuration that will automatically deploy all of our Docker containers with one command. So as you can see, each of these are given some parameters for starting up, including port-specific information that are used by the HTTP and TCP interfaces used by these applications, as well as some file system resources that are called volumes. So with this script, we can perform a sudo docker compose up command to actually start off all the infrastructure. Before we do that, what I'll do is do a sudo docker ps just to show you that nothing is really running. We have our GitLab runner and a registry up and running, just because those are outside the Docker Compose deployment. But so if we start up the infrastructure now, what we can see is that it will start up everything automatically with one command. And this operation takes quite a while to actually start, but here you can see it spinning off GitLab, Jenkins, SonarQube, and the web interface for it. That's actual GitLab server. So since this takes a while to run, I'm going to pause the video here and then pick it back up when everything deploys properly and we're ready to demonstrate. Alright, now that we have deployed our infrastructure, we can actually use the sudo docker ps command again in order to take a look at each application and make sure that they're running correctly. So here we can see GitLab, SonarQube, and Jenkins all deployed, and they've been up for about 20 minutes now, and GitLab's reporting to be healthy. So that's all good. Another requirement for this project was to use a GitLab container registry in order to store the Juice Shop image. So to accomplish this, a few commands had to be run from the command line, utilize the default registry that's provided with GitLab. So I have those commands listed here that we use to actually pull down the Juice Shop image from the public facing internet. And what we did after we did this initial sudo docker pull was we tagged that image with the name that we want it to be recognized as within our registry. We then pushed that image. After that, we removed all of the local cached images for Juice Shop that we had available, and from that point the image is in the registry, available for us to actually pull down fresh using this tag that we created. So if we were to go into the command line again, what we could do is take a look at the images listed by doing sudo docker image ls. What we can see here is that there's actually no containers that have anything to do with Juice Shop. But since we've registered it in the registry, what we could do is perform that sudo docker pull command, referencing the container by the tag that we created for it initially. Execute this command. It takes a little bit of time for it to download and extract, but once this is complete, we'll actually have that Docker container for Juice Shop readily available and downloaded. So we would be able to actually deploy it via normal sudo docker start command, or we could add it to, say, the docker compose YAML script to launch it on startup if we wanted to do it that way. So this will just continue extracting, but that's the entire gist of it. And there you can see it completed. So now if we do sudo docker image ls again, we can see that there's now this image that was taken from the local container registry. So that's pretty cool. And we see that the registry is operational as well. Alright, next up I will quickly describe the steps that were taken to get interactions between GitLab and Jenkins set up. So first, whenever a push is made to a GitLab repo, the triggers within a GitLab-CI YAML file, which is specified here. It's committed on the Juice Shop project within GitLab and the repository for the project. Excuse me. So we have this script that defines the CI actions that GitLab will take whenever a push is made. So here you can see we have this portion of the job called trigger Jenkins. And what this does for us is that it performs a curl command. And this curl command will effectively just start a Jenkins job. We've pointed this command to our Jenkins server URL. Specifically, we've pointed it at the Juice Shop build, providing it with a token that was generated within Jenkins. And here you can see this is the actual value of the token. So curl is actually able to access Jenkins and initiate an action on that server using this command. And we can see that credential if we go into the Jenkins page under configure for the job, scroll down a little bit, we can see that that authentication named doit is available here. The token, the actual token value is hidden for security purposes, but this is where we were able to generate it, and now it's referenced by name. Alright, so another set of credentials that were needed for the ability for Jenkins to access GitLab and pull the Docker container stored within the registry. And to do this, what we did was we provided a credential, a username password combination, as a named credential within the global Jenkins admin page, as shown in this first line item here within Jenkins credentials. So this credential is set and it's used within the Jenkins configuration of the actual job. So if we scroll down here, we can see that this credential is used on line 7 when we actually register with the GitLab interface, and this would allow us to pull containers from the registry. Finally, there was one more authentication step, setup step that we had to take, and this was also listed under, I believe it was, yeah, sorry, it's right here. So this is the authentication setup for using the SNCC tool. So what we did for the SNCC tool to integrate it with Jenkins is we downloaded the Linux binaries onto the server and made sure that they were publicly accessible by a Jenkins user and process. From there, we created an account on the SNCC website where we were provided with a personal access token to use in combination with the binaries. And this personal access token was used directly within the Jenkins job as seen here. We point it with the API parameter we provided it, the value of the token. So now that all of the sets of credentials have been properly assigned, a Docker image container has been added to the registry and a curl trigger has been added as a GitLab push action. All that was really left was to code the Jenkins pipeline logic, which is what you see right here. As shown here, performing the scan was relatively simple. We had to perform the authentication information for GitLab to access the container registry under the build stage here. Under test, a separate stage within the pipeline, we manually invoked the SNCC binaries and perform a security scan of the image that was pulled, which is specified right here. Now, unfortunately, whenever we tried to pull the image from our local GitLab registry, our team was faced with SSL errors. These were quite pervasive, and after several hours of debugging, an alternate plan was put into action. Rather than scanning the container pulled from the local registry, we simply pulled from the public-facing registry that's on the internet. Although this does not satisfy the requirement of pulling from a local registry, it did allow us to demonstrate the execution of the security scan, so we went ahead with this approach. So now, our actual scans were configured with a severity threshold set to high, which you can see right here on this line item. This will cause a build exhibiting a high severity vulnerability to fail, which will be apparent in the Jenkins logs. Now we can do a quick little demo and see what would happen if we were to commit some code to the repository. So now that we are in the actual repository, we can create a simple test file, and if we add this to the Git history by committing it, and I'll just call this example commit, what we could see when we push it up, let me supply my username and password. So that pushed up an example commit that I just created to the repository. So now if we go into GitLab, we could go to the jobs pane, and what we should be seeing quite soon is that a job was spun off because we have the GitLab runner container running in the background that kind of kicks off these. So I might have to refresh it a few times for it to get running. So here we go. This spun off two jobs. One is targeted for the curl command and another is targeting for that SonarQube command that we saw earlier in the GitLab CI YAML file. And these run sequentially. So what we could do is we can inspect this job, and this will bring up the console output. And what we can see here is that it was tied to this commit that I had just pushed the repository, started by me. And what we see here is that this curl command executes at the end of the script with that personal authentication token that we provided, and it's aiming at our Jenkins server. So what this curl command will do is kick off a build on that Jenkins server. So if we migrate over there, we should see, at least shortly, yep, so this build has already been kicked off. We have number 80 running right now. So what we could do is click into this job. Once it loads, we should be able to open up the console log to see all of the debug information. We'll click that, let it load. And as you can see right now, it's actually running the Jenkins job. So the CI job in GitLab kicked off another job within Jenkins, and what's happening here is it does the container pull. Followed by that, we see that it's running the SNCC commands. So here it's doing a configuration setup, providing the API token, and then here we see that it's actually running the container test command, and it's pointing to the publicly facing juice shop container on the internet, and it's assigning a severity threshold of high. So right now what's happening is it's running that container in a sandbox environment, and it's performing those security scans on the container, and it's going to be analyzing if any vulnerabilities are apparent within that binary. So that'll run. It usually doesn't take too long, so I might refresh. We might be able to see it. If not, I can show you the output of a past job because it's going to be the same. There's been no source code changes or anything like that. So if we go into job 79 for a better example, what we can do is go into console output. From here, we can see the output of the last job. It says a critical severity vulnerability was found in APK tools within Juice Shop. And it's kind of nice because what SNCC does, it provides a URL, and this will point to the actual vulnerability information that was detected in scans. So if we open that link, it would take us to this page. And what we can see here is that a vulnerability for an out-of-bounds read was detected within the Juice Shop container. And it gives you a nice description of why this is an issue. So apparently Juice Shop uses a libfetch library that has a vulnerability known for it. And it provides a scoring of a 9.1. So this is what's basically being used for that scoring for the severity threshold. So it passed the level of being critical. So it will cause that Jenkins job to fail because of that. And down below here, it actually, oops, I scrolled too far. It links to the CVE and the CWE that's known for that vulnerability. So it gives you a good deal of background information about all of the problems that are detected with the container. And based on running this type of a setup, a developer can write code, have it built by GitLab and stored within a container registry, so that an external tool such as SNCC can be used to analyze the created binary for issues. This type of infrastructure is ideal for DevOps team because it's totally automated and provides a fast and reliable process of performing runtime testing and security analytics on an application. And that concludes the presentation for part 3 of the course project. I hope you found the material interesting, and I thank you all for watching. Have a good one.